Okay, so since this is what we are trying to prove, let me just put down it must be closed now, so that you can see that. So let me just put down the information that says triangle ABE is congruent to triangle ODE. So we have proven that. Now what we need to finalize or do is that we're going to take this proportion of AB, see that, so AB over OD, that it's a pattern, it equals to, can come to B now, BE is equals to this two again, same pattern, DE. So there's a pattern there, sequence, yeah. And then we take the last ones, A and E, you see that, so it's going to be AE, and then we do the same thing here, OD. Now the reason why I want to have this close by is for me to be able to choose, meaning that I have to eliminate one here between this or this or this. So I'm going to check here. I do have my OB here, I'm happy, sorry, my AB, and here I do have my AB. So I'll consider this row just for now. BE, I don't have BE anywhere there. DE, I don't have DE anywhere there. So here we can see I do have my AE and my OD there. So I'll also consider that one. Okay. Let me check. I feel like I'm making a mistake here. Yeah, it's supposed to be OE here. OE here is not OD because of OE, the last one. Okay, I think everything now it's set, so I could take those two and write them below as they are. AB over OD, it's equals to AE equals to OE. So I just copy down this back here. Now I'm going to cross multiply the two. If I cross multiply, what do I get? Say therefore I'm going to get AB multiplied by OE being equal to AE multiplied by OD. Now if you can check, this side is completed, right? This side, the right hand side of the proof is completed. The only thing now that is left is going to be removing of the OE and then having an OF. Now let's bring back our diagram and check if OE and OF are something similar. Yes, okay, so that is the same thing. As you can check here, OE and OF, they are both radiuses from the center to the circumference, from the center to the circumference, that is a radius. So all the radiuses are the same. So it is the same as from this O up until to this point there. That is going to also be equal to those two. So anything from the center to circumference, we call it a radius, and is going to be equal to any other line from center to the circumference. Now we can conclude by saying, but we know that OE, it's equivalent, meaning it equals to OF. And then let me just remove this one, and then I can put a reason to say the radius. What about the radius? Equal radius. I don't want to say radi. I don't know if I'm going to be correct if I say it's a radii. Okay, or we can say the radius is twice the diameter, because we already know that EF is a diameter. So any one of those reasons will make sense. And then we can say now AB multiplied by OF, it's equals to AE multiplied by OD. Then you complete your 7 marks there. Then we are going to be looking at the next question. Alright, 10.2. They say it is further given that AT it is equals to 3TO. Prove that 5CE squared is equals to 2BE multiplied by FE. Okay, let me just rewrite this question again, closer to our diagram here, and then we will do all the necessary demarcations that we need to do. They say AT is equals to 3TO, that is given, right? And then what we are required to prove is that 5CE squared is equals to 2BE multiplied by FE. Okay, I'll try to zoom a little here so that we can see which is sevenza. Okay, now the first thing that I'm going to do here, I'm going to convert what I am given in a simple proportion form, meaning I can divide both sides. Okay, what it means is that before we do that in proportion, what it means is that AT, this one, it's equals to 3TO. So it is 3 times the distance of TO. That's what it means. It means in this case, this is 3 times, not 3 units, meaning that it is not 3 units. It is not a distance. It is just 3 times bigger than this one. That's what it means. Now, if I have a situation like this, and then I know that I've already proven that these are parallel, right? So check what I'm going to do. I'm going to rotate this guy like this. And the reason why I'm doing this is because I want you to be able to see that I have a proportion triangle, which is ADO. See that, where this is a parallel line. See that? So this is the triangle I'm talking about. I want to highlight it with red pen so that you can see it properly. Good, this is it now. So the parallel lines will run through there. You can see the parallel lines. So this is a proportion. So if this is 3:1, this is also going to be 3:1, like that. See that? So that is the first triangle that I have established to be in a proportion form. Okay, let me check if I can see. I think there are 2 there. And then the other one, check, I'm going to rotate this again like this. Good. So if you can check, let's hope this 2 this triangle there, see this triangle there, the big one, see this one, it is also a proportion triangle, meaning that it also part of these 2 parallel lines. So this is going to be equivalent to this to that, or we can say the whole thing to one of the side, the whole thing to one of the side. Either way we're gonna do it is okay. Now, since we have done that, let's go back to our question. I said we have AT being equals to 3 times TO. So what I'm going to do here is I'm going to put this in proportion form, and I'm going to, sorry, this is where I've written it. I'm dividing everything here by TO, and then if I'm dividing everything by TO, I'm dividing here by TO both sides, so that I'm left with 80. I'm rushing now for my 5 marks. I mean, exam time is ticking. Okay, so I'm going to be left with 3 over 1. So remember, this is not a distance, it is not 3 units. It is a proportion. So good, that's what we have for that. Now we need to take into account that I'm bringing this again. I have 3, I have 1, but remember, now I've written it upside down. I hope you can see. I don't have to erase this. So you can see that also, because CD, it's equivalent to this by these demarcations here, it means that also this is going to be 1. You see that? So let me just put this one straight. Let me just put this 3 straight like this. It means now the whole thing here, AE, you see that AE, it is going to become 3, 4, 5. Now I do have my AE being equal to 5. But you must be clever here, because we have 2 triangles now. And then I'm looking for CE. So CE, I know that, okay, I have used those sides. I'm good with them. And then let me check BE. So BE, this is BE, it's part of this side, or this green triangle. And then FE is also part of that. Okay, so we need to use these 2 triangles to be able to find answer on. So the first one, we have used the red one to be able to write this proportion, and then from that, and then we have analyzed that this is the proportion that we have from the triangle, right? So now we need to move to the other triangle and check what we can do about that. Okay, so I think we should do this before we look at the other triangle. Complete this proportion here. How are we going to do that? Let's bring back this. So remember that I said AT over TO is equivalent to AC over CD. So this means that where there's AT, it's also going to be equivalent to AC. So here at 80, so 3:1 is also equivalent to AC over CD. Yes. Now, okay, let's bring back the green one. Now the green one here, I can see I have this, but now the problem is that I have BE, not FE. I do have FE, but now I have BE. So I do not think we can use proportion in a green triangle. No, because you can see the space won't be covered. So we're going to look at another alternative, considering the fact that you should have BE and FE and CE as well. So the only thing that I have so far is AE being 5, and then what about CE? Okay, so I can see CE can be 2, because this is Yes, this is 1 and 1, so that can be 2. Okay, so let's try to put that information down. Okay, so what I'm saying is that AE, we have already proven that AE it's equivalent to 5, and then we said CE it's 1 and 1, which is 2. So CE, because we are trying to bring those CE to help us in that situation, that is equivalent to 5. So it's like AE over CE, it's 5 over 2. So we have a proportion of one line, which is the length of AE, is the length of AE there. Let me zoom out there. So AE, the whole distance there is 5, then these two is 2. So this and this one, they're equal. So that is the given information that we can use for now. So I'm making a proportion using one line here, if you can be able to see. Now because I have that, I'm going to make my AE subject of their formula. In fact, not AE, my CE, I'm going to make it subject of the formula. So I need to keep having this thing there. So this is 5CE squared being equal to 2BE multiplied by FE. So I need to find CE here, so I'll make it subject of the formula. So how am I going to do that? I'm going to multiply by C. Jesus, there we have it. So I don't think we made CE subject of the formula. Instead we made, let me say, yeah, we made AE subject of the formula. So we are going to leave it like this for now, and then now bringing this back, I wanted to see something, because previously we have used the congruency of the big one, which is ABE and ODE. So we have now in this case CE, right? As you can see there, we have CE. So using the big one, ABE, yeah, you will notice that BE is part of the big triangle. It's good. But now, what about FE? FE, in this case, it is not part of the small triangle that we did, but rather it's going to be part of the big one, bigger than this one, which is FCE. So if we can conclude that the angles are congruent, it means angles are equal, it means that those triangles are also similar. Now, which triangles am I talking about in this case? So why is this thing blaring? Come on. Okay, so it means now what I'm going to do is I'm going to say triangle ABE, which is this big one, is going to be similar only if those angles are equivalent, right? So remember that E is going to be common. So angle A is equal to angle O on the small triangle, but is also equal to angle F on the big triangle. So it means that this angle here, it is going to be equivalent to F. So A and F, they're going to be the same, and then E and E are common, right? So it means now this angle here, which is C1, it is the one equivalent to that. So C, like that. So I'm going to rewrite this information down here quickly. So triangle ABE is similar to triangle FCE. So remember that this is proven. We just used a different triangle, but you can still use okay. Now let's do our arrangement. So we're going to say AB as well here over FC. So, and then BE, it's going to be partnered with CE, and then AE is going to be over FE, like that. Good. Now I can start to see that here I have BE and FE. So BE and FE, it means I'm going to eliminate this one and be left with this one here. Okay, now things are looking good because my AE there is that. So let me just substitute that first. Substitute this there. So I have BE over CE is equals to, so this is 5 over 2 CE over FE. Good. So I have FE, I have CE, I have that in squared. So I do have I do have everything there sorted out. Now let me just cross multiply this and this and that and that. So I'm going to have BE multiplied by FE, that is equals to 5 over 2. So it's going to be 5 over 2 CE squared, right? Then I can multiply by 2. If I multiply both sides by 2, I'm going to have 5 CE squared is equals to 2 BE multiplied by FE. Good. So I just rewritten this in instant form. So that is what you are going to have there. So if you didn't see, I didn't pay attention to that, I'm very sorry for that, but I hope you can see we just cross multiplied over there, and then cross multiplied over here to get this and that here, and then this multiplied by that, it's going to be this that remain there, and then from this stage